Hello students, welcome back to rdchemistry. In this video, I'll explain the concept of Faraday's first law. According to the Faraday's first law, the mass of the substance deposited, let it be equal to W, or released during electrolysis is directly proportional to quantity Q or the charge passed into the solution. Now, what is Q stand for? Q stand for the quantity and W stand for the amount of the substance. We also have got formula Q is equal to I into T, where Q is the quantity in terms of coulombs. I is the strength of the current in terms of amperes, and T is the time in terms of seconds. Remove the proportionality. So W is equal to one constant Z into Q, or W is equal to Z into I into T. Okay. Now what does this Z stand for? Z is known as the ECE. ECE. Electrochemical Equivalent. It is the electrochemical equivalent. Electrochemical equivalent. Electrochemical equivalent. That is the ECE. Now that is a constant. Now we'll find out the Z value. There's a formula to calculate Z value. That is equal to equivalent mass divided by 96,500. That in terms of coulombs here. Okay. So what is the equivalent mass? Equivalent mass is calculated as, for the metals, it is the atomic mass divided by the valency, or equivalent mass is also equal to molar mass divided by change in oxidation state. Change in oxidation state. Therefore, we can again rearrange it. W is equal to Z into I into T. Z is nothing but E divided by 96,500 into I into T. Okay. Or you can also extend it in terms of atomic mass divided by valency into 96,500 into I into T. Okay, fine. Now read this question. How many liters of chlorine is a gas Cl2, will be liberated by 100 amperes of current passing for 5 hours through the molten sodium chloride, that is the NaCl. Now here 100 amperes nothing but the strength of the current I. 5 hours stand for time. Time T is equal to 5 hours. We have to convert this into the seconds later. Okay. So how many liters? For that we'll calculate mass. You know that if I take 1 mole of Cl2, atom mass of chlorine is 35.5 into 2 atoms are there. So many grams. This is the molar mass of chlorine. You know that at STP it will occupy 22.4 liters at STP. Now you find out when you pass so much of current, some grams will be liberated, is equivalent to how many liters of chlorine. Okay. So we can use this one. W is equal to ZQ, which is equal to, that is the E divided by 96,500, right, into Q is equal to I into T, right. So we'll calculate E value separately. E is equal to equivalent mass of the chlorine is equal to, so we'll take in terms of the element chlorine, Okay. So initially the chloride. Chloride will become chlorine molecule. So I'll be taking chlorine atom. So its atomic mass is equal to 35.5 divided by valency of the chloride is equal to 1. So it is 35.5. Then I'll calculate Q is equal to I into T together. I is 100 amperes into time T is equal to 5 hours. 5 hours is converted into minutes. Minutes into the seconds. So ampere seconds are nothing but the coulombs. So this is equal to 18 into 10 power 5 coulombs. Okay. So therefore, I have now E is equal to 35.5 divided by 96,500 into I into T. It is 18 into 10 power 5. Okay. And this is equal to, on calculation, get 35.5. So remove these hundreds. So 965 into 18 into 10 power 3. And this is equivalent to 662.2 gram it comes. Okay. Of chlorine. So much of the chlorine will be liberated. Okay. So many grams of chlorine will be liberated. Right. Now, you know that 1 mole of Cl2 is equivalent to 35.5 into 2 grams of chlorine. If I take, that will be occupying 22.4 liters at STP. So therefore, 662.2 grams of chlorine, if it is there, is equivalent to how many liters? So we'll have to cross multiply 662.2 into 22.4 whole divided by 35.5 into 2 times. And this comes to be equal to 208.9, okay, liters, or you can take it as the 209 liters approximately. Okay, this is a method. I'll give the alternate method now. Now, what is the alternate method? Okay, so we'll be using the equation chloride Cl minus become half mole of the chlorine gas plus 1 electron, or chloride becomes chlorine atom loses 1 electron. Okay, or you can make use of 2 chloride ions becoming chlorine molecule and 2 electrons are lost. Okay, chloride minus 1 charge, x is equal to minus 1, chlorine Cl2 2x is equal to 0, x is equal to 0. So change in oxidation state is 1 unit, difference 1 unit. Okay, right? Now let me take this equation 2Cl minus giving chlorine plus 2 moles of electron. Let us take this part now. 2 moles of electron means is equal to 2 Faraday, and this 2 Faraday is equal to 2 into 96,500 coulombs, right? And this is equal to 1 mole of chlorine, and this 1 mole of chlorine in terms of mass will be 35.5 into 2 grams. Correct? Got it? We are passing Q is equal to, already calculated previously, that is 18 into 10 power 5 pascals, using Q is equal to I into T, already calculated from the question. So if you have got 18 into 10 to the power 5 coulombs passing, then how many grams will be formed? Okay, this on cross multiplication, similar thing, it is 35.5 into 2 into 18 into 10 power 5 whole divided by 2 into 96,500 will end up with the same mass, 662.2 grams of chlorine. Okay, this is the second way of finding out the mass deposited liberated. Now do the calculation. Same thing. 1 mole of Cl2 is equivalent to 35.5 into 2 grams, occupies 22.4 liters STP. Therefore, 662.2 grams if it is there, how much it will occupy? Same answer will get. So approximately will get as a 208.9 liters we are going to get. Okay. Hope this is clear to you. This is one of the important questions. Please do subscribe, share and like the videos. Thank you for watching.